Hi everyone, welcome back. I hope you watched the last video where I provided a quick introduction to Noise2Void. This is a deep learning based denoising technique, and if you haven't watched that, this would be a great time to just have a quick, at least parts of it, forward it and check out what Noise2Void is at a high level. And I also urge you to read the paper so you understand exactly how it works. You can use it even if you don't know how it works, and that is what we are going to do in this video. We are going to use Noise2Void to train on an image and then use that train model to segment the same image or other images if you want. And if you want to be notified of these videos, again, please hit the subscribe button if you haven't already done so. And while you're there, also hit the thanks button if you're feeling extra generous. Okay, getting back to today's topic, I am going to use Google Collab, so all of you will have access to it. Of course, this can be done using any IDE on your local system. And we'll look at the requirements in terms of what's required, what version of TensorFlow, for example, or what version of Python and so on by looking at their GitHub page. So without any delay, let's go ahead and jump in. So here is their GitHub page. Again, you just Google search for Noise2Void, you will find their primary GitHub repo, and it's actively maintained, right? So this is October 2022, and things have been done like last month. So pretty active, pretty current, and you can see the documentation is amazing. In fact, the tutorial I'm going to show you is right out of their documentation, out of their examples, so you can get more out of it. Although I did modify a few things, especially in the next video, where I'll show you how you can handle your own multi-channel images and Z-stacks and all that stuff. But the base itself, I copied their code and then I edited it for these purposes. And the way you install that is obviously they're saying, okay, create new environment with Python 3.8 and whatever the CUDA is required. And within that environment, install TensorFlow 2.4. So the key requirement I see here is TensorFlow 2.4. And then it's basically pip install Noise2Void. That's exactly what I have done offline, but also on my Google Collab account. So let's go through Collab right now, line by line. And I am not hoping this to be a very long video, but I will not rush through at the same time. And the image we plan on training this on is this night sky image that tend to be obviously noisy. And there seems to be some halo, something going on there. I'm not sure if that's a camera artifact, but that looks structured, right? So hopefully it doesn't clean that up completely. I mean, remove that completely, but you can see a lot of noise, random noise that should be cleaned up, and all the stars should stay put. Again, Noise2Void is going to clean up only the unstructured noise and not any structured features that you actually have in your images. Okay, with that information, let's jump in. And as I mentioned here, this example is for training Noise2Void denoising model using RGB images. And these images can be PNG or TIFF. They cannot be JPEG. If you're using their way of importing images, but you can use your own scikit image or OpenCV to load images, and then once it's in the NumPy format, it doesn't matter. But they recommend not doing that with JPEG, because when you save images as JPEG, there is already some sort of a loss, some sort of a compression going on. So I'm not sure how good the images are cleaned. Although in this case, I took this image, a screenshot from my Google search, and I saved it as PNG. And I started using it. That's it. That's not how your input images need to be. They should be either native TIFF or PNG, but hopefully it works in our case to some extent. We'll see. What I'm going to show you is for RGB images, like meaning it's multi-channel images, right? But the same technique can be applied to your black and white grayscale images, whether they are tomography images or MRI or SEM images. The same technique can be applied, except at one place you just change the axes to only X and Y and not like X, Y, and channel. That's it. So I'm not going to do another video. So you wait 2 more weeks just for, black and white images, right? Grayscale images. Okay. Although they do have an example of grayscale image on their side, they have, if you go to examples, you'll find a grayscale example right there if you need some reference. Okay. So let us go ahead and start by installing TensorFlow 2.4. So let's give this a few seconds. So I'm going to pause the video and then continue as soon as this is done. It should be probably 20 seconds or so. Okay, so it's done installing. So let's go down and see what it says. It says, okay, the following whatever, and you must restart the runtime in order to use the newly installed version. So let's go to runtime, restart runtime, and yes. And by the way, I've already connected my Google Drive, mounted the Google Drive right there just by clicking that button. So I stored this file that I'm going to use in my Google Drive, and I'm gonna refer to that folder wherever that file is. Okay, so the runtime is restarted. So let's move on to installing our Noise2Void. Again, it's just pip install N2V. I haven't well, obviously I tried this once before, and I haven't run into any issues, so I don't expect anything surprising. Hopefully we'll see. And this should be, again, just a few seconds right there. So that's done. Okay, now let's go ahead and look at what versions of TensorFlow and Noise2Void we are working with. 2.4, 0.3.1 for Noise2Void. Okay, so let's import all our dependencies. And again, this is NumPy, as you know, and from Noise2Void models, we are importing the N2V config and N2V. And from the utilities, we are, CSV deep utilities, we are importing plot history, so we can plot the training curves. Again, this is optional. You can use your own if you want. You can use pyplot if you want, so that's just optional. And we are importing a couple other libraries from Noise2Void and pyplot for plotting, urllib. I don't think we need that because we're not getting anything from any URLs. And also we don't need zip file. I just took these header directly off their webpage, off their examples. In their case, they are using an example that you need to download from a URL, and it's a zip file, and then you're using zip file to unzip it. So that, but I just left it right here. Okay, and all of these are optional, but it doesn't matter. Let's go ahead and run these lines. I'm just making sure you understand exactly what the need for each of these libraries is. Okay, now for training, we can load a bunch of noisy images from a directory. And they provide, Noise2Void has something called DataGenerator that can be used to read the data, and also, of course, as the name suggests, as a data generator that can help us in dividing our images into patches. So we don't have to worry about, oh, my images are large, they're of different sizes. You can apply these, divide your images into patches, so all of those are of the same size. All the patches are same size before they go into the network. So that's the advantage right here. So let's go ahead and you define our data gen as N2V data generator. So once it's initiated, now let's go ahead and use that to read our images. Now you can also use your other favorite way of reading images. You can use scikit-image, you can use OpenCV. Again, the next video is going to be using that approach, but for now let's stick with what they have here. And one other note, by the way, the input images, they need to be in float32 format. That's one thing I learned while working with my own images, using my own scikit-image import. And when you're importing your images using your own method, make sure you convert them into float32. You don't have to if you're using their data gen, because it apparently does that automatically for you. Okay, so loading all images using this load images from directory, and that's part of your data gen, right? So you already defined your data gen right there. So we are using load images from directory, and this is basically where my images are. So what I did was, let's go to my drive. I just want to show you Collab notebooks, and under data, under N2V, Noise2Void, I have, let me expand this a bit, a directory called PNG images. Under PNG images, I have like 3 images, a bear, a flower, like the sky image. And I can use all of these images as input to train a model. In this case, I just want to use one image, which is the sky image. So that's exactly what I'm doing. So let me collapse this side so you have a lot more room. So that's why I added a filter to this directory called sky star PNG. So it only looks at all the images that start with sky and end with PNG. Here, the dimensions that I defined are Y, X, and C. So Y, X, width and height, and C is for number of channels. So this is our RGB image. And if this is only a grayscale image, that's just YX, right? Or just don't use any of that. The DIMMs, the default I believe is YX. And if you're working with 3D images that are grayscale, then it would be ZYX, and 3D color images ZYXC. That's as simple as that. So once you read the images, these images are read as a list. Because even though I'm only reading one image in this case, but you can read multiple images from a folder, from a directory, and all those images are stored as a list. Why as a list? Because each of your images may be of different size, and you cannot put different sizes into a single array, right? NumPy array. That's why it's actually holding all your images as NumPy arrays inside a list. And from that list, I'm getting the 0th image and printing the shape. And also right there, sometimes your images may have an alpha channel, meaning instead of only 3 channels right there, you may have 4 channels, where the 4th is the alpha channel. And there are a couple of lines to drop that and only have the first 3 channels. So that's it. And if this is irrelevant, delete those. So let's go ahead and run this, and we should see that we have one image of size 510 by 738 by 3. And shape without alpha, we don't have an alpha right there, so it doesn't matter. Shape without alpha is exactly the same, and the data type of the image is float 32. And I just said first image because you may be reading multiple images. You may have like 20 sky images, but I'm just looking at the first one right there. Okay, now that we know we have that information, I'm going to print the same information again down here. And let's have a quick look at that image. We already looked at it, but there you go. Yeah, so it's noisy, you have these stars, and you have this some sort of a halo going on. And now I'm going to divide this image, this 510 by 738 by 3 image, into patch sizes of 64. So I'm defining the patch size right there. And now I'm defining my patch shape as 64 by 64. Again, if this is a Z, like a 3D image, then you need to have like, okay, I don't know, 32 by 64 by 64, whatever the dimensions are. We'll get to that in the next tutorial, but just giving you some information up front. Okay, so our patch size, we want to divide this image into 64 by 64 patches. And how do you do that? Within DataGen, you have generate patches from list, because we have a list of images, and that list of images may be, I don't know, 2,000 images. And we want all those 2,000 images divided into patches of 64 by 64. That's what this does right there. Okay, since we only have one, it divided my single image into 616 patches of size 64 by 64 by 3. So this is my patch. Again, you can print out the patch shape. Okay, now that the patches are there, we can actually divide them into training and validation sets. Okay, how do we do that? There are many ways. You can think of your own way. The way I did it is go ahead and look at how many we have, 616, multiply that by 0.8. So 80% assigned to training and remaining 20% assigned to validation. That's what I have done here. So let's go ahead and do that and run those lines. And now let's see. So of 616, 492 are used for training and 124 are used for validation. And now let's go down and how to docstring method. So basically what they're saying is there is a lot more details that you can actually get out of this docstring. I hope you know how to get that, but if not, again, these guys did a great job, and let's do that. Why not? So you do datagen.generate patches from list ? Right? So let's go ahead and run this line. It should open up a screen on the right hand side, and here is the explanation for docstring right there. Yeah. So there you go, number of patches, all the information about it. Okay, now let me close that, get back to what we are doing, and let's look at the 2 patches, one that from training, one from validation, just visualization purposes, right? So there is the training patch and there is the validation patch. Obviously, these 2 are different patches. One came from the training set, one came from the validation set, but we are just visualizing it. A lot of noise, hopefully we'll take care of that. The configure file, go ahead and read this. I copied this directly from their documentation. So Noise2Void comes with special config object, and all the details are part of the configuration object. So you can modify this configuration, including like what patch sizes and everything, number of epochs and all the information, just like any other configuration for deep learning, right? So very similar. So this is how we are setting our configuration. So I'm defining a train batch of 32, like it loads 32 images at a time. For training, it's up to you what you want to define there, but my configuration is N2V config. X is my training images, and unit kernel size is 3, right? When you're defining your unit, what kernel size would you like to use? I have no reason to change any of that. This defines the unit architecture, like the first 64 filters right there. And depth is 3. Again, all of these things can be changed, but again, the only thing that I touch is probably not even this. Train steps per epoch. I usually leave steps per epoch as my training images divided by the batch size. And number of epochs, let's leave it to 20. Usually, again, they say for better results, like 100 epochs or something. So I am going to just leave it to 20 for this video purposes. And training loss, mean squared error, batch normalization true, and blah, blah, blah. And anything else do we change here? Yeah, patch shape, patch size is the, I mean, it's 64 by 64 is the patch shape that we are using. And N2V manipulator uniform with CP. Again, if you want to know more about it, you can go back and where is it? Uniform with CP. I think they mentioned something right there, if I can find it, sorry. Normal fitted. So these are pixel manipulator, normal without CP. Where is uniform with CP? Let's see, N2V manipulator. Anyway, look at a couple of these, like sample, for example, if you check normal without CP, it samples the neighborhood according to a normal Gaussian distribution, but without the central pixel. And normal additive is another option. Normal fitted is another. Identity is another option for patch sizes. For Noise2Void training, it's possible to pass arbitrary large passes, blah, blah, blah. 64 by 64 is okay. Yeah, I failed to find what normal with CP is, and hopefully you can find that out from documentation. But that should not matter. I have always used this, and it worked fine. Yeah. And neighborhood radius of 5 default is also okay. So now let's go ahead and define our config right there. So it creates this config file with all the information that we just went through. Okay, now we are getting to just giving a model name. Again, you can give any name. The default name that's given here is N2V 2D. You can just call it, I don't know, N2V 2D stars, for example. Yeah. And base directory is models. That means when it goes here and not here in the drive, but under your storage right there, it's going to create a folder called models. Within that, it's going to dump this. I'll leave the left-hand side open so we can see what's going on. And we are defining a model as Noise2Void with this configuration file, with this model name, and with that base directory. So it has all the information to store that model. So let's go ahead and run this. And there you go. I am not sure if it creates that model directory. Let's update this. Yeah, it already did. You see how it created this models directory right there? And if I go into the models right here, N2V 2D stars, and within here you should see your JSON file, but also once the training is done, your H5 and all that stuff. So let's go ahead and run this model.train. Again, this is my training data. This is my validation data. Let's go ahead and run this. 20 epochs should be pretty fast because we only have a single image, and that image is not that large. I mean, I think we have 600 patches, but still it should be pretty fast with GPU help. And after this is done, we will have a H5 file right here, which would be our trained model. And we are going to use that H5 file to segment future images. And the same image also, because remember, it learns from the same image, and you can denoise the same image. But you can take that trained model, like I showed you in the last video, and apply it to other images. Okay, so there you go, 13th, 14th, and each is like pretty much a second. And at the end of this, it should store my config file, sorry, the H5 file, I believe, HDF file, yeah, right there. And let's refresh the left-hand side to see, yeah, there you go, weights, best, and it's storing the best one. It's also storing the last one, yeah? Okay, and you can see all the other metrics as the training is going by. Okay, so with that, let's go ahead and also plot the history. Yeah, validation, not much. Training, it's doing a pretty good job. Again, more images and more epochs. Yeah. But I'm confident it does a good job on this image, even based on just the training, because in our case, our training image is equal to our validation image equals to our test image. Okay, so now let's say you're done. You can shut down, you can walk away with this weights best H5 file. Now you would like to use that for your denoising purposes on a day-to-day basis. So this is the process down here. I'm not going to give you another file for denoising. I included everything here, but you can copy from here down into a different file and be okay. So these are all the libraries that we are going to. I don't think we'll need this one again. Some of these I just copied and I did not bother deleting those lines, but we are going to use matplotlib for pyplot, and we are going to use numpy and n2v.models. We are going to use that n2v. So we did that, and now our model name is what we call n2v underscore 2d underscore stars. Yeah, so this is my model name. Get this from the base directory, and this is the configuration for my model. Okay, now the weights are loaded, and now we are ready to segment or denoise our images. So which image? I am reading the same image. You can use again scikit-image, whatever method to read your images, but make sure that you get the image into the right format. Like for example, let's read this float 32 D type, and I'm using imread from, I believe, matplotlib right there. And yeah, so nothing, no tricks, right? So we have our image, and how do you predict? Model.predict, just like you do in Keras. And our image and our axis is Y, X, and Z. We have 3 channels. So let's go ahead and do that. We're almost done, guys. In case you wonder when this is going to end, well, you can always forward it if you think it's too slow. But anyway, so we have our prediction. Let's go ahead and plot it. And by the way, if you look at, let's add one line, pred dot d type. Actually, I wanted to look at shape. If you look at the prediction shape, it's 510 by 738 by 3. So it's like your actual image. Yeah, so you're ready to plot it. So let's go ahead and plot this and look at before and after. So isn't that great? That's the before image, and that's the after. Most of the noise is gone. The halo, I can see if I squint my eyes, it's kind of there, but I can tell that the random components are probably gone from this halo. Again, this is just a JPEG image converted to PNG. Please work with native PNGs and TIFFs to get the best results. And yeah, I'm super happy with that. And if you want to save this, again, we imported a library called save TIFF image compatible. I think we just did that right here, right there. Go ahead and use that to save this as a as your output. That's it. So I hope you appreciate the simplicity when it comes to using it in Python or using it in Zen, like I have showed you the last time. There's the 3D part. If you go back to 2D, you can see how the denoise image looks like compared to the original image. And the same type of usage if you use in ImageJ. I haven't used it in ImageJ on multi-channel, multi-dimensional images, but probably you can do certain tricks to get that done. But either way, whether you're coding it yourself, this you have to appreciate the power of Noise2Void. Okay, enough appreciation, enough praise. We'll keep praising this in our next tutorial, which is going to be exactly the same, hopefully much faster. We are going to use our own loading, like using scikit-image, and we are going to load a Z-stack multi-channel image, only 2 channels, but multi-channel image. So I'll see you in a couple of weeks in that tutorial. Again, do not forget to hit the subscribe button. Thank you.